Okay, so what we're doing today, we're going to be talking about the second section. It's on segments. That's what we're going to do today. So if you haven't already, make sure that you go online, do your little login for lunch. If you're going to eat lunch today, do that right now. We're going to take some notes. We will get an assignment today. It'll be out of the book. It'll be due later this week. So it'll be due probably Thursday this week. It'll be kind of a shorter turnaround. It's pretty much the same stuff we talked about yesterday, but I want to practice more of those last few problems where you have to do a lot of algebra. But we'll go over kind of the measurement stuff one more time. I'll do one of those, then we'll move on. But I'll give you a little bit of time. I know you're logging in, getting that little form filled out. I'll take attendance, and then we'll get started here. So there's kind of our outline today, just so you kind of know, so you kind of get a feel for how the homework's going to look as well. A lot of the problems in the beginning are just measurement problems, and then there's a select few, I should say, that are going to be ones where you have to do some algebra, solve, find an x, plug it back in, that type of thing. But we'll kind of walk through each. I'm going to go through maybe one or two measurement problems. We'll kind of see what you need. We'll see if it confuses you at all, and we'll try one of each type, one metric, one customary, if that's what's necessary. And then we're going to spend most of the class today just practicing these algebraic problems. These are the ones that I kind of showed you yesterday. It was like the end of class. I really threw you for a loop when I threw a pretty nasty little problem at you. And we're going to do the same thing today. And these are the ones we need to practice. They're the ones I want you to get good at. Kind of mixing some algebra ones, some geometry, and really fine-tuning it so that when you get to your problems in your book, you feel comfortable and you know how to do them and you understand the process of what's going to be involved. Because there's a couple problems I didn't discuss yet. Or at least one that we need to go through on this algebra for sure. That they'll throw you for a loop when you first see it. All right. Questions on kind of the outline today? Okay, but again, we will have a book assignment. We do probably Thursday this week, so you have a couple days to work on it today, tomorrow. Turn in Thursday. So, all right, let's start with a measurement problem. I just want to give you something that's very similar to what the book's going to do. We'll go through one or two of them just so you kind of know. So I'll just kind of do a very terrible looking picture here. So here's my little bug. I don't know what kind of bug that is. Ant, spider, I don't know what that is. All right, and so let's say the book has something like that. And what they're trying to do is trying to help you figure out, the measurement that's required. Okay, and they're gonna give you a picture. They'll automatically have the ruler printed in the book below each picture. So each picture will have its own form of measurement. So it'll be centimeters, the metric system, or it'll be in inches for the larger objects. And they're gonna ask you for what is the length, from one edge to the other. And they try to do a pretty good job of it. I'm gonna slide the 0 over just so you can see that there. The 0 starts there. Okay, there. A little bit better. And you had to figure out, how wide that object is. Well, when you do it, obviously we didn't hit, if you can tell this, we didn't hit 1 centimeter. No, we're only doing a few millimeters. So whatever millimeter you hit, we're hitting 4, your answer would be 4 millimeters. Okay? It'd be 0 centimeters, 0 centimeters, because you didn't make it quite to 1, but it'd be 4 millimeters. Now, if you put 4 millimeters, it's fine, I'll accept that. Now, there's another way of writing this, that if you have centimeters and you have millimeters after it, you can make that a decimal form. Whatever the centimeter is, this number goes here. Whatever this millimeter is, it goes behind it as the decimal. And you'd put centimeters as your answer if you change it to decimal form, right? So the actual millimeters would be the decimal after it. Because centimeters, the metric form goes up to 10 hash marks. So that's the perfect amount of hash marks for decimal form, because decimals go in base 10. So you don't have to do any weird conversion. Whatever the millimeter is, that's the exact decimal that goes after it. So it doesn't matter if you went out. So maybe the object was a lot larger, and you went out multiple centimeters. Whatever the centimeters is, you count it. Whatever one you've least went past, then that number goes here, and the millimeters goes after it. Does that make sense for the metric system, what you're going to do there? I don't mind whatever one you have. You want to use the top one versus the bottom one. I don't mind. They're the same answer to me. So if you check the back, they have one versus the other, you know that you've done it fine. Questions on the metric system though? I think that's easy, right? There's just whatever the decimal is. Okay, now, the one that I'm kind of worried about is the US customary system. That's the one that has like the 16 hash marks, right? It goes to inches. That's the one where I really just want you to count the hash marks. That's really what I want you to do. So, whatever object this is, I'm just going to put a shape. I think they have a couple where you're going to measure a shape. So let's say we're measuring this triangle, the base of the triangle. They have the ruler printed in your textbook, because that's how every problem works. Here's 0 inches. Maybe they'll have, here's 1 inch, here's 2 inch, here's 3 inch. Okay, so we've definitely went past 2 inches, let's say. So we know we're at 2 inches and something else. 2 inches, and we're looking for the fraction that comes after it. This is where it's really important that you count the hash marks. Are they going in 16s like normal rulers would? Are they going in 8s? Are they going, whatever hash marks that they're going by? So on this one, I'm going to go by 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 16 will be the number 3. So we landed on 1, 2, 3, 4, 5, 6, 7, 8, 9. We landed on the 9th one. So that's 9 out of 16 hash marks. That's what I'm looking for. I don't care that you know where half is, and you know where 1/8 is, or 3/4. I don't really care. Just count what hash mark you've landed at, and that's the number that goes on the top, and the bottom is however many total hash marks there are. Does that make sense for the metrics, or for the US system? That way, you're not that person that's like, God, I don't know the hash marks. You don't need to, just count. It should be out of 16, hopefully. If it's not, whatever the bottom number is, however many hash marks you have until you get to the next one, that's the number that goes on the bottom. So it took me 16.
Or if you can...
if you can simplify it,
do
it.
All right.
That's fine. If you don't, it's fine. I'll have both answers on my paper anyway. So if you don't want to simplify, that's fine. I'll have it. I'll check both. So, because if you guys don't know, I make the answer key when you guys are working. I do the same homework on a piece of paper. So whatever I send you, I do it myself too. So that way you have an answer key. Even though I have one in the back of my book, I like to have the answer key with just your answers in there. So if you ever have a question, you can always ask. So, all right, questions about the measurement form? Does that make it a little more easy to adapt to? That's you're comfortable with it? Okay, so those, I think you have six of those, I think, where they're just kind of random. Sometimes they're metrics, sometimes they're US customary system. Just make sure you count the hash marks so you know kind of what to put. The metric system, if they ever go to the metric system, I'm almost guaranteed they go by base 10s. So you should be able to go decimal form on that one if you need to. Yeah, so those are the first few problems in your homework. They're kind of scattered in there, but that's a majority of the homework. Now, the select few problems you'll have later are these algebraic. These are the ones I want to spend a lot of time on today, where you have to find it, because they're just so much more difficult than that stuff. It's just a radical departure. So let's go through a couple of these. Does anyone still need the example on the board for any reason? Okay, because I can leave it there if you want it. Okay, all right, let's go. you need one later, I can put it up there later if you want to see another one. So don't be afraid to ask for it. All right, let's go through the next one. So now we're going to do some algebraic based problems with segments. Now again, remember a segment has a definite starting and stopping point. There's two endpoints to it. And pretty much what they're going to do when they draw these, they're going to always have like a third dot. No, I don't care where it's at. Let's call this A, B, and C. I'm not going to get real creative. Now, if you read your problems, sometimes they won't have the picture drawn. And that's a weird one. I'll give you an example off to the side. So sometimes in the instructions above your problem, it'll say, let B lie in between A and C on AC, like that. Maybe that's in the instructions up above the problem that you're working on. What they're trying to explain is that picture right there. I don't know where B is. It's on a slider, right? It could be anywhere. It could be in the middle, it could be off to the right, it could be off to the left. B is somewhere in between it. So if this is what they put, this is the drawing I'd have kind of in my head. I don't care that's not to scale, because maybe this is supposed to be a bigger segment than the other one. It's just what they're trying to explain to you is that it's one line. It's one straight line. Okay? So just make sure that that you can kind of draw that. I'm a visual person. I need to see the drawing, just so I can kind of figure out where the labels go. Now, below the problem, maybe this is, I'll just make up a number. Let's say this is number 9 in your homework, right? Now they're going to give you all the parts you need to label the picture. So they'll say, okay, AB is 12. BC is X plus 6. And let's say AC is, let's go with like 28. And the question is, find X. So that's, that's part of the question. That's maybe in the instruction, find X. And find BC. No, the length of BC. Now, the length of BC shouldn't be that hard on this problem. So I'm going to start easy and kind of work my way to the hard ones. I want to go through at least 3 of these, I think. So again, they're giving me the lengths of these segments. That's why they left the bars off of these. They're like the actual length of them, the actual distance. But they want me to find X in that algebraic problem, and then find BC. So once I have X, I have to go back and plug it in into BC to go find it. Even though I don't need to. If you kind of did some common sense there, you'll see it here in a second. All right. Questions on what the problem is going to be providing you? Now, I'm starting with an easy one, so I can show you a common sense way of doing this one, so you don't have to spend a lot of time thinking about it. When I do this problem, I'm going to go label the picture, just so you can see what I'm talking about, because some people, when they see this, they don't understand what you're given, like what you're even looking at. I'm going to put these on that picture. So A is 12, or A to B is 12, so that's this distance here. That's from here to here, right? That's 12, and whatever measurement that is, I don't know what it is. The other one is X plus 6, and the entire distance is the 28, right? Yeah. I don't know why, that's what I need to have in like my homework when I do it. I like to see it. I can connect the dots and solve for X once I see kind of what I'm given here. All right, now there's a couple different ways you can do this. And I've kind of started with an easy one. I'm going to show you the generic way of doing it, and then I'll just show you like the shortcut on this particular problem, because maybe you can solve the shortcut already. But when you first start this problem, you can add the 2 small segments together. I consider these small. AB is a small segment, BC is a small segment. You can add these together. That's called segment addition. And when you add these 2 pieces together, what should they equal? Yeah, exactly right. They should make the entire stick. They should make the entire 28. So that's one way you can do it. So 12 plus the X plus 6, right? You can physically like add them together, and that should equal the entire stick, the entire 28, or whatever they provided there. Maybe they don't give you the 28, they give you some weird algebraic thing. Okay, does that make sense? that's pretty much how I do most of the problems. So that's like the generic way of doing almost every single one of them. You have the two small pieces equals the big piece if they were to happen to give it to you. No matter what it is. I mean, these could be anything. All three of these could be algebraic stuff. You know, x plus 12 and 2x minus 2. Like, they could just have weird stuff sitting here. And you just have to plug them into the respective spots. Just remember, the two small pieces add together to make the bigger piece. So you have to kind of see where the labels go. That's why I like to draw it. And then you just solve it using Algebra 1. Now, on this particular problem, especially on a couple, you don't need to do this. Because if you just kind of think about this a little bit before you started the problem, what was the length of the entire stick? 28, right? The other piece was 12, right? So the whole stick is 28. This piece is 12. That means this stick right here should be 16, if you think about it, right? 12 plus 16 makes 28 when you add them together. So I already know what BC is. I didn't really have to do anything special on this particular problem to go find it. I already know the entire length should be 16. That could help you to solve it. Because now that you know that the BC is 16, you could just do this problem. And then go ahead and just solve that. So what would my x be in that case? 10. 10. Okay, so you already have that. That's one way you can do it. There's some problems you can just do that. It's totally fine. Maybe you just solve the shortcut right away. Maybe you just saw that when I first wrote the problem on the board. That's great. Do that. Maybe you just saw that right away. But if you didn't, and you want to stick with this method because this works literally almost for every single problem that you have, it's the same problem, if you can see it. Because I'm going to solve this, right? I could add the 12 and 16, 12 and the 6 together to make 18, right? Because I have the 12 and 6, I would subtract the 18 across. So I would subtract 18, subtract 18, right? That's the part of algebra where you have to do it to both sides, right? That's balancing equations. So the 18s are gone, I'm left with x, and this turns out to be 10. So the x did turn out to be 10 anyway. So like, no matter which way you do it, it's gonna work. It's just whatever one you prefer, which one makes sense to you. To me, yeah, like the common sense, just seeing the 16, fine. But this is the one you'll probably want to stick with, because there's gonna be some nasty problems where they throw some weird stuff at you, and you just have to trust your Algebra 1 skills to solve it out. Okay. That was the answer for that one. We've solved both parts. This is kind of the goal, is to find those two pieces on these problems. Is there any questions on that first one? Okay. Now, I did say they're going to get difficult as we go. So now let's change it up. Let's get just slightly more difficult so you can see this. Let's go to the next one. Okay, so this will be another problem in there. I'll just use the same letters, A, B, and C. Let me get rid of these labels here. All right. Okay, so new problem, I'm going to call this, I'm just going to make this up. Let's say this is number 12 out of your book, let's say. So this is another example. Let's say this is number 12. Okay, so here's what they give me. Okay, so let's say this is the problem. Now again, the goal, just so you know, on this particular problem, because they always have these off the side, they want to know what x is, they don't want to know what AB is. They could be decimals, they could be whole numbers, whatever they are. Okay, so those are the two parts, just kind of know that off to the side. They'll tell you in the instructions what they want you to find. They might say, you know, find x and find yz for all these problems. Maybe that's in the instructions up above. Find YZ or AC or whatever it is, whatever letters they give you. All right. Now, the 7. I want you to look at that top line of number 12 here, this mythical number 12. This is new notation. I don't think I've ever shown you this before. That is an equal sign with a little tilde above it. If you don't know the tilde on the calculator or on a keyboard, so if you're on a normal QWERTY keyboard on your computer, the little tilde symbol is over to the right of the number 1 key on the actual, it's like right below the escape key on most keyboards. But they're putting it above an equal sign. That is on purpose. What that symbol is, it's a new symbol, it means congruent to. So I'm gonna label that. This symbol means congruent. It was a new vocab word we had right, before the end of class yesterday. It was the last vocab word of the day. Congruent means equal in size, shape, and measure. So that means these two sticks are supposed to be identical to each other. They're the exact same size. That's what it means. Why they don't just put an equal sign? Because you're thinking like, why don't they just use equal? If they're equal, just put an equal sign. When you compare geometrical shapes, shapes are congruent to each other. Algebra, like numbers, could be equal, but geometry shapes are congruent. There's a difference in vocab there. So what I can do here on this picture, on this particular problem, is that A, B, and B, C are the same size. I can put the little hash mark in there like I told you yesterday. These little symbols mean that the sticks are the same size. Even though the picture looks terrible, this length should be equal to this length. That's what it's telling me. So if you know that fact, what should AB be equal to in terms of length on this particular problem? 20. Like I didn't even have to think about it. You know they're equal. They said they're congruent to each other, so both of these better be 20. And duh, that makes total sense with the number they gave me at the bottom. If this is 20 and that's 20, what's the length of the whole stick? 40. So duh, all the numbers are starting to make sense now. So I didn't really need to do too much. So now you could do it by two different ways. You could do it by the algebraic way like I showed you earlier, or you can just do it by the shortcut knowing that 6x plus 10 should be 20. So you can do it either way. So if you wanted to set this up, since you know that should be 20, and solve for x, perfect, do it. Because you know that that's what that 6x plus 10 should be equal to. Or, if you're the person that likes to label the picture, if you're the person that wants to go, okay, this is 6x plus 10, and that's 20, and you want to add them together, you add the two small pieces together and make that the entire stick, you can do that. That's the beauty of doing these problems. If you know the concept that you can add the two small segments together to make the large segment, it will work every single time. But sometimes it's just nice to see that shortcut so you don't have to do all the extra work. All right, questions on the either setup. They'll give you the same answer. That's the beauty. I'm expecting this one to be a decimal. So, how do I solve this? It doesn't matter. Each one will be the same even if I add or subtract them. How do I do that? Please.
Subtract the 10, so 20.
Good. Subtract the 10. The reason why. This little acronym we use when we have to subtract, you're absolutely right. Right, it's called SADMAT, right? It's PEMDAS backwards. When you solve equations, that's the acronym. You're absolutely right. We have to add or subtract first. So you have to look for what you need to add or subtract. I need to subtract the 10. So the 10s are gone. 6x is equal to 10. So you have to get rid of the 10s, right? That's whatever they're adding to the x. You have to get rid of it first. Now what?
Divide the 6 by 10.
The other way around. 10 by 6, yes. I think I know what you're talking about. Divide the 6's over, boom, that's gone. You divided 10 divided by 6, what is that? 1. Let's see, you have a 4, carry down the next one. What is that? 6, 1.6, and got a bunch of other numbers after, is that right? 10 divided by 6.
Good job.
Is that what it is? Somebody have a calculator?
Yeah. You know, before people used to put algebra into my head, I used to be able to do that.
Yeah, so 1.6, there you go. And there might be more decimals, I'm just thinking of that. All right, and that would be the answer here, 1.6-ish. It'll be, you can have decimals, it's fine. That's why I'm trusting that you have a calculator, because you will get some decimals, it's gonna happen. All right, questions on that second problem?
Seems easy enough.
Yeah, seems easy enough, right? If you just know the concept, right, this method can work every time for almost every problem. If you just understand what they're giving you, right? That you add the two small pieces makes the big piece. You could work that, or if you just start to see the shortcuts where you know what that number should be, you could set those parts just equal to each other and solve that out. Either way, you're gonna get 1.6, no matter what formula you used. All right, let's do the last one. This is my last example of the day because I want to give you some time to work so you can ask questions. You can, I don't want to turn you loose at home if your parents don't understand or if you don't understand it in the first place. Let's do one more unless you have some questions still. But I want to do one of these where I make it a little more difficult. These have been a little too easy, I think, for what we need to do. All right. I'll use the same lettering, so B is lying in between A and Z. All right. So let's say this will be number 21. I'm making up numbers just for whatever problems these are. So let's say this is number 21, and let's go with BC is 14 plus X, and AC is 3x plus 10, and AB is x plus 4. I don't know, let's go with 4x. Let's go 4x plus 4.
This one looks scarier.
Shouldn't. I just need to make sure I don't have any weird negative numbers. So let's make that a bigger number instead of 10. Let's go with 50. Yeah, let's make it. I gotta make it a big number. I don't want to have any negatives. That'd be awkward. Okay, let's go with that. And the question on this one, find x, obviously. Let's find x. That makes this thing work. And I'll give you guys choice. You want BC, AC, or AB?
BC.
BC, let's go with that. BC, we'll figure out that little chunk. So these would be the questions that they want on this one. That's in the instructions up above the problem. Find BC. So pay attention to what the question says. Find, this particular segment. So we're finding BC on this particular problem. So whatever x is, we have to plug it back into BC. So that would be this part right here. So if we find out x is 2, we plug it back in, that'll be 16. So that's what we'll have to do. If that's the case, it's not. I'm just making up numbers. Okay. Does everyone understand the setup? Now, what should we do first? What would be the smart thing to do first?
Make a line.
Yeah, draw it, right? I would draw this picture and label all the parts. I know some of you might not need to. I like to see that so I can see what parts I'm supposed to be adding together. So I'm not just going, okay, it's the top two added together equals the bottom one. I don't know that. I need to figure out where these things go. Some of you will figure out the lettering system and you'll figure out the shortcuts for that. Here's A to C, B is somewhere in between it. Don't care where, because it's what the instructions say. Okay, AB, what is AB up here? It's 4x plus 4. Okay, there's that part. BC, 14 plus X. Okay, there's that part right there. And the whole stick, A to C, is 3x plus 50. Okay. So we got our parts. So what do we need to add together and set equal to? So we need to set up the form. Please, what do you got?
4x plus 4 plus 14 plus x equals 3x plus 50.
Exactly. Because the two small parts on this one are the AB part, and that part. Those are the two things you have to add together. These two parts I put in green. And then you have to set equal to the entire stick. The entire stick should always be on the other side of the equal sign, no matter what it is. So you're absolutely right. 4x plus 4, 14 plus x, that better be equal to the 3x plus 50. Absolutely agree with that. Okay, thank you, good setup. Somebody else now, somebody new that maybe hasn't volunteered yet today. What would be your first step at solving something like that? what would you do? Right or wrong? Throw it out there. Doesn't matter. Okay, please.
Add the 4 and 14,
Yeah, right? Why would you add the 4 and the 14 together?
because they don't have an X after each other.
Yeah, they're what we call like terms, right? They don't have X's. So yeah, I'd add the 14 and 4 together. So that makes what, 18? Absolutely. So far so good. Please.
You could add the 1x plus 4x.
Yeah, we're gonna add X's because why?
Like,
Like terms again, right? You're absolutely right. So 4x and 1x, what's it making? 5x's? Okay, now we got to a point where you can't add anything more together, right? On the left side by itself or the right side, because you don't want to add the 5x and 18, right? One has an x, the other one doesn't. The 3x and the 50, one has an x, the other one doesn't. So, now what?
You're gonna cross over you're gonna take one of the numbers onto the other side.
Exactly right. You're gonna drag them across, you're gonna subtract them, however you want to think of it. I'm a very visual person, so like the way that I do algebra in my head is that I drag the 18 over here, and when I drag it across the equal sign, it becomes the opposite on the other side. That's just my visual aid. So I'm dragging the 18 across, and I'll subtract it over here. Instead of adding it, I'll subtract it. It always does the opposite to the other side. That's just how I think of math. And then I'll bring the 3x over, same thing again. The 3x was over here, is being added, I'll subtract it over here. So I'll subtract the 3x. So this is my new step. This is what I'm looking at. Maybe that doesn't, maybe that does not work for you, I'm sorry. Maybe that person that likes to put like subtract 18 to both sides. Same thing. Okay, so 5x and 3x, what do we get?
2x.
2x's. Okay, that's a nice number. 50 minus 18. 32.
16.
Yeah, and then the last step is divide the 2 over, because we add and subtracted first, and now we're going to multiply or divide, and you're absolutely right, we divide by the 2. Divide by 2 to get the x by itself, and you're absolutely right, we get x should be a 16. So, that's our first answer we should have came up with, so 16. Now we have to take that and plug it back in. Because now we have to answer the final part of the question. So don't forget to do the final part. You found X, you did all the hard work. Have to plug it back in. We have to go figure out where to plug it in. We have to find BC on this particular problem. So go up to BC, I plug it in, so I have to plug in 16 here. So what is that going to be, 30? When I plug that 16 into X, and there's my 2 parts. If I was doing my homework, or if I was grading yours, I should say, I do want to see some algebra steps. You don't need to show me every step. I know I'm going kind of overboard showing you every line of work. It's kind of nice to see that. But I want to see something, right? Nothing's more frustrating than seeing, no one set up, the formula, and then suddenly you just come up with 16 all of a sudden. Like, that's a lot of steps to do in your head. Maybe you can do 1 or 2, but not all of them. So I do want to see something. How did you come up with that? What was your formula to start with? Somewhere in the middle, then what do you end up with? Then coming over here, I want to see you kind of plugging it back in. Be kind of organized in your homework on this one, because it can get kind of messy. You're doing a lot of algebra. It can take a lot of paper sometimes, even though I'm not assigning a lot of work. So, okay. Questions at all about any of the problems I've kind of provided you? Okay, I'm gonna turn you loose on homework here. This is the assignment that will be due on Thursday this week. Let me write it up on the board. Due on Thursday of this week. We are on page 18. Page 18. We're doing numbers 1 through 8, 10 through 19, and 21 through 25. Typically I don't go in order like that, but these first couple sections they kind of have some good problems right in the beginning. I don't need to go through all of them. Kind of skipped around a little bit, skipped a problem here and there. Definitely something you should be always thinking about. We do have vocab on my tests, so make sure you are kind of going through the sections, section 1, section 2. Kind of look at some of the vocab words that you're doing, some of the vocab words that were highlighted in yellow. keep looking at those, because sometimes, you know, I haven't covered it yet. It's something that I might mix in later when you really need it. So kind of keep that in mind. You should always be checking the vocab words in your textbook, because those are words that are free game for the test. That's a good practice to do in college too, because college professors don't tell you that you know, they'll have lectures multiple days in a row, but or more than half the stuff in your tests are just found in your book that you had to read on your own. They don't tell you that when you first get to college. They expect you were doing it. But there you go. What day?
Thursday.
Thursday. Was that the 3rd? That's the 3rd. September 3rd. I'll put that on the board later today. If you need to, take a picture of it. Write it down somewhere so you don't forget. That might be the question of the day today, like what's the assignment, when is it due, that type of thing.
Did you ever get the logins for our online?
No, not yet. So, nope. Hopefully at some point today I can. I think I have internet hooked up today, so. I know. You guys have like 5 more minutes, so. Turn on the right here.